Hello, my name is Sandra Monroe, and I am the Director of Product at Anaconda. Today, we'll be talking about how to manage your Snowflake Python environments using Anaconda. First, let's get started on some of the fundamentals. What is a package manager? So a package manager is a tool that helps you manage the dependencies of your project. A dependency is a code that is required for your program to function properly. These often come in the form of packages. Packages can also have their own dependencies. Managing all of these dependencies can be hard because packages may require specific versions of their dependencies, and it is easy to break something by modifying these dependencies manually. So having a package manager allows you to quickly install, run, and update packages and their dependencies. So what is an environment manager? An environment manager enables you to create and manage environments, allowing you to lock down or freeze the software package versions. This gives you stable, consistent software to run on, leading to stable and consistent execution. Another key feature of environment management is that once you define a stable environment, you can share that environment between collaborative teams, again, keeping consistency in mind. So environment management allows you to maintain three areas: consistency, stability, and reproducibility. Now that we've kind of set the stage of what is a package manager and what is an environment manager, we can talk a little bit about how Conda makes this experience very seamless. So Conda as a package manager lets you search for packages to download, install packages, or uninstall packages. With Conda, there is no need to build packages locally, which can be burdensome. Conda determines which packages have updates and whether those updates are compatible and can be applied, which makes Conda environments upgradable. Conda also manages all the package dependencies, which is no easy task, as you can see. This graph here shows the dependency graph of TensorFlow. So you can see how complex and intertwined all of these packages are with each other. Conda analyzes package dependencies when you create a new environment, modify an existing environment, meaning installing new packages, updating existing packages, or removing existing packages. When installing a Python package, that package may depend on other Python packages to run. These dependencies can have their own dependencies, which forms a very complex dependency graph. Also, since package release updates happen at different times, you have to manage which pieces you want to update and when. Conda determines all of the package dependencies and installs them along with your package. If a package dependency conflicts, for example, if they require a different version of the same package which aren't compatible, Conda will then tell you. Let's talk about how Conda manages environments. So Conda environments let you isolate different groups of software packages that you want to use for each one of your projects without interfering with other software on your computer. Conda environments are creatable, meaning you can control what's in your environment. They are savable, meaning they persist even if you're not using them, and they don't disappear unless you delete them. They are loadable and switchable, meaning you can load whatever environment you want by activating it, allowing you to switch between environments very easily. And they're exportable. You can export an environment and share your Conda environment, making it reproducible across the same platform. Conda environments won't change unless you change them. These environment management features provide stability, reproducibility, and collaboration when using Conda. Reproducibility, since a package version is locked down, you know exactly what is in your environment. And collaboration is since environments are easily exported, they can be shared using the same environment. Now let's talk about how we install Conda. So there are two ways to install Conda. Conda is one of the most popular data science platforms to run on Mac, Windows, and Linux platforms without being an admin. You get Conda when you download the Anaconda distribution or Miniconda. Miniconda is a minimal installer for Conda, which includes Conda, Python, their dependencies, and a small number of useful packages. It is a command line interface only for all platforms. Anaconda distribution includes about 250 packages, saving you the time of installing commonly used packages individually. It provides a command line interface on all platforms, along with a graphical user interface called Navigator. Conda is ready to use out of the box. The installer does all the setup for you, but you can choose to further customize your Conda configurations. For Mac and Linux platforms, you can use Conda commands in your terminal window, and for Windows, you can use the Conda command in your Anaconda prompt or Anaconda Navigator as a graphical user interface. Now let's talk about how to use Anaconda with Snowflake. If you're using Python with Snowflake, Conda can help you manage your Python packages, dependencies, and environments. If you're using the Snowflake connector for Python for developing Python applications to connect to Snowflake, it is available as a Conda package, making it easy to install, use, and manage with Conda. If you're writing user-defined functions or stored procedures in Python for Snowpark, Conda connects to the official Snowflake Conda package channel, letting you install packages that are guaranteed to work the same across your local environment and Snowpark. You can specify Anaconda packages to install when you create Python user-defined functions. When queries that call Python user-defined functions are executed inside a Snowflake warehouse, Anaconda packages are installed seamlessly and are cached on a virtual warehouse on your behalf. When developing your Python applications for Snowflake, Conda makes it easy to pull those packages from multiple channels to pull into your Python environment. With one command, you can create an environment with packages from your Snowflake channel, which will run on Snowpark in order to develop and test your Snowflake application. Additionally, you can use Conda with your favorite IDEs like Jupyter Notebooks, Microsoft Visual Studio, or PyCharm. You can also use Conda with your favorite CI/CD tools to automate testing, like Travis CI for Mac and Linux, and GitLab CI and GitHub Actions on any platform. Conda uses your current ecosystem tools as well. On Windows, Anaconda comes ready to interact with Microsoft Excel and run your code in a Conda environment in a Docker container. So you can use what you have today and be able to run your applications the way you do today. Conda just makes it so much easier. Now let's get started. So a couple of things before we want to get started on creating our model and application today. First, we want to make sure that you download Anaconda. Then we'll want to validate the version of Conda that you have. Next, we'll want to set up your Snowflake channel in your Conda RC file. And then finally, we want to view your Conda RC file to validate that the channel is set up. As a best practice, especially if you were creating UDFs in Snowpark, while you can install Snowpark from default or even Conda Forge, using the Snowflake channel exclusively will ensure that the versions of deeper dependencies like NumPy will match what is available on Snowflake. And this way you don't run into errors. Meaning if you use all the packages on the Snowflake channel, things will run very smooth and seamless. If you go outside of the Snowflake channel, you may run into a few errors because the versions don't match. Now let's look at a few of the basic Conda commands before we get started. So one thing we want to do, once we've downloaded Anaconda, we want to make sure we can look at the version of Conda that we have, and we can look at some of the configurations around Conda. The version will at least tell us the version that we're running today. Show configurations will show you all the configuration values, and show the sources will show you all the sources from those values and identify those sources. And Conda info will give you all the current information around your existing install. Let's look at some of the basic environment commands. So Conda environment manager functionality is really easy to use. And so looking at your Conda config file, you'll be able to understand how everything is all set up. So the first thing we want to do is you want to look at your environment list and see if look at all the environments you have there. If you've never created an environment, no environments will be there except for your base environment. And then you want to create a new environment and then activate that new environment. And then when you are finished with that environment, you want to deactivate that to take you back to your base. Now, this last one is basically kind of giving you some information around the project we're getting ready to create, along with how to share your environment. So the project we're creating, you will see that the first line, the Conda create, the name, Snowflake Bike Share Pittsburgh, and all the packages we need in order to create this environment. We don't need very many packages, but we'll see that there's a lot of dependencies that come along with that package. Then we want to activate our environment. And if we want to share this environment, we can export it out as a YAML file. And if we want, once we do export it out, someone can come in and create an environment using our YAML file, and they can activate their environment on their local machine. So this gives a lot of versatility about we can create one environment, and as we build on that model using this environment, we can share that environment out. To ensure that only the packages are only installed from the Snowflake channel, you can create your environment using a restricted override that says only pull packages from this channel. Finally, let's pull it all together so that we can kind of talk about what we're going to demo today. You should have already set up your Snowflake channel in your Conda RC file and created your environment and created a YAML file for that environment. Because we're going to be using Anaconda and our model with Snowflake, we want to make sure our environment variables in our bash profile are set. So these will be your Snowflake username, password, and your account. If you think you've already set them, you can verify by looking at your bash profile. You can also check your Conda RC file to make sure your Snowflake channel is set. And then before you activate any of your environments, you'll want to set your variables to make sure that prior to activating your environment. Now let's walk through using the model and what you're going to create. So the first thing we're going to set up is the Snowflake database, schema, and warehouse. Then we're going to load the raw data from the Pittsburgh Healthy Ride, along with the weather data for Pittsburgh from NOAA. Then we'll clean and prepare the data in order to engineer some features. And next, we'll use scikit-learn to train the model. And finally, we'll build a user-defined function using our training model to make our predictions. This demo will provide a model that a director of a municipal bike share system can use to predict the total number of rides given the forecasted weather conditions, current month, whether today is a holiday or a weekend. This model also is very useful for the director to decide capacity of the bike share system. So we're allowing a director to kind of predict, let's say for Labor Day, what's the weather prediction look like? How many bikes do I need to have and at what location? Now let's get into our demo. So I've opened up my Visual Studio just to kind of walk you through what we're doing. As you can see, a lot of the stuff we've already talked about is here. What the bike share is, kind of all of the stuff we've already talked about in our presentation. And then the actual Conda create Snowflake bike share Pittsburgh, this is the channel. You can see here that we've also defined out what version of scikit-learn we're wanting to do. So a couple of things I want to point out here. To begin with, we want to create our Conda environment using packages from Snowflake channel to ensure the compatibility between my local Python environment and the Snowpark environment. Since we're going to build a scikit-learn model and persist it as a file, it's important that we ensure the exact same version of scikit-learn is used on both my local environment and Snowpark. And that is why we have to actually call out that version right here. And then we'll want to activate our environment. So because I've already created the environment, I'm just going to activate it. So now that I've activated my environment, I'm able to kind of see what is in that environment. I'm going to do a Conda list so you can see, even though we've only added these files here, you can see that the dependencies with this file are much deeper. So there's a lot more that gets added, even though you only added a few packages. There's all these dependencies that come along with the environment. And one of the things I wanted to point out is, like I said before, we had to have a certain level of scikit-learn, a certain version. So we wanted to make sure that we pulled in this version, and all the dependencies that will make that version work are also pulled in, so that we are definitely only working with that version, because that's going to be the version we're building our model on. So now that we've done that and we've set up our environment and have everything pulled together, we're going to go ahead and open a Jupyter notebook. So I've brought up my Jupyter notebook. If I go to my account, you can see that I don't have a database called Bike Share. I don't have any of that set up. And that's what we're going to do in our first stage. We're going to stage and load all of our information and data. So let's get started there. And the first thing that we're going to do is we're going to pull in all of our required Snowpark packages. And then we're going to connect our local variables, the ones we set up previously in our local bash file. And then we're going to set up our database, and we're going to activate that session. And then finally, we're going to create and load the bike table. So we're going to pull in the raw data, convert it to a CSV format, then pull in that data into a file, and then we're going to set up our SQL database. So we're going to have all of our table columns set up. And there they are, they're all set up. And then the next thing we're going to do is we're going to do the exact same thing with the weather. So we're going to pull in our weather data, we're going to convert it, we're going to set up the table. And then we're going to close out the session once the table is set up. And then I should be able to go back over here to the warehouse. And you can see there's now my Pittsburgh bike. And if I look at my public, you can see I have my two tables set up with all of my parameters set. The next one we're going to do is we're going to go in and prepare all that data. So again, we're going to set up our database, get our users, and then activate our sessions. And then we're going to clean and prepare the data. The first thing we need to do is join the bike data and the weather tables to provide a daily count of the number of rides and the max temperature. So here we've got the number of rides and the max temperature. Since we're using the Snowpark data frame functions, we want to clean the data for the rides that both start short, where the bike is returned at the same location. Extract that data from a portion of the start time of the ride, group by and count the number of valid rides, and finally join that information with the weather data. So here we've got the max temperatures, the rides, when whether it's a holiday. And so that's the next UDF that we're going to run. We're going to be able to state if something is a holiday or if it is a weekend. And so we want to make sure that we create UDFs to go over each row and extract the name of the month and a Boolean value, whether that date is a weekend or a holiday. And finally, the full training of that data set table will be constructed by calling a UDF over the date column and writing those results back into Snowflake. Now we have all of our data. We have our temperatures, the number of rides, the months. Is it a weekend? is it a holiday when the max rides happened? And it gives us all of this information so we can start training our model. So we'll close out that session and we'll come here to train our model. We'll go ahead and set this up again. Now that all the training data is ready and stored in the Snowflake table, we want to take a portion of that training to train the machine learning model using scikit-learn. To do this, we use a Snowpark data frame called sample by function, which allows me to perform a stratified sampling over the table to ensure that the training data is an accurate representation of the full data set. By using the sample by to sample every evenly over the month column, we can ensure that a third of the rows from every month are extracted into a pandas data frame in order to train the scikit-learn model. We don't want to pull all of the information because that is just a huge amount of data. We should be able to pull a sampling of that data and then take that sampling and provide our X and Y values. And now that we have our X and Y values, we're ready to train the scikit-learn regression model to predict the number of bike rides given the maximum forecasted temperature, the month, and whether the day is a holiday or not. And then finally, the model needs to incorporate two processing steps. The first one is the one-hot encode that the strings of the month column can and apply the standard scalar to the other columns. So this allows us to take all of this information and come up with a good extrapolation. And then we can come up with a gradient regression model. Plotting the feature importance validates our hypothesis. As you can see here, the maximum temperature is the largest factor predicting the number of rides, with the smaller contributions being the weekend or holiday or the month column. And finally, the final step is we want to optimize our model to a local file. We will use this file in the next section to build our user-defined function to use the model to predict the number of rides. So we'll use this model here to predict our ride prediction model. And that is our final one to look at. And so we'll go ahead and go in here and run. And as you can see up here, we are actually pulling in a lot of importing the packages that we have stored in our environment. We can import those directly into our notebook. So now that the model has been trained and saved, we can build a user-defined function on Snowflake so that we can use that model to predict the number of rides using a fully trained set of the data we prepared earlier. One of the things we can take out of this is we use the pandas UDF. The prediction function expects a data frame with the 4 columns and will return a pandas series for the prediction of the number of rides. The important aspects of the permanent prediction of user-defined functions are: 1, create a stage where you can upload code that will be stored. Here, this is called model stage. Load the model into memory and ensure that we have the input feature names in the correct order by using the input features names from the one-hot encoding processor. And then declare the exact version of scikit-learn. And here, as you can see, we declared it the 1.0.2 that we pulled into our environment. And use the Snowflake types, panda data frame type and pandas series type to type hints to provide fine-grained typing per column. So this will give you a lot of information around that. Now that the UDF has been registered and has been used, we can pull all this information in, and we can use a Python function to make predictions over the whole training set as a Snowpark data frame. So as you can see here, now we have our predictions. And finally, since I've saved the output to a prediction UDF to the new table in Snowflake, I can then use the reg R2 to compute the R squared score between the actual daily number of rides and the predicted number of rides using that scikit-learn regression model. And here you can see this is our prediction score. And finally, we can close our session. Now that we've kind of demoed everything, I just want to make sure all the Jupyter notebooks that were used to build this demo, including the ingested data into Snowflake, are all available for download. I will make sure that everybody has access to this anaconda.org location. And if you have any questions or concerns, please reach out to us here at Anaconda and we can walk you through any more demos or give you a little bit more insight in how we created this demo. Thank you.